let's basically proceed with our discussion on electrochemistry. So this is our second session. We want to dig a little bit deeper into electrolysis and see what is it exactly and what mechanisms are actually involved in there. Why do we have certain ions being discharged in preference to others? What are the factors that really determine that? And then we also look at the application of electrolysis. Where do we really use the knowledge of electrolysis? Okay, so let's start this quite fast. Electrolysis is when you have a chemical reaction happening because of the influence of electric current. You have some substances that do not conduct electricity when they are in solid state. But when they are dissolved or when they are in molten state, they can conduct electricity. So we call these substances electrolytes. So for example, salt, which is sodium chloride, when it is in solid state, it will not conduct electricity. When it is dissolved, you will have the sodium chloride. When it is dissolved, it will give us, when it is in aqueous solution, it will give us the sodium ions and also the chloride ions. So it is these ions that will basically conduct the electricity. Okay, so that is the explanation provided by what we call the ionic theory, and we looked at that earlier on. For us to understand the process of electrolysis quite well, we need to first understand what we call the electrolytic cell. What are the parts that make up the electrolytic cell? In your exams, such a diagram can be brought to you, and there are a number of questions that you can be asked. You can be asked to name the different parts, but they can also tell you to describe what can be observed at these electrodes, whether it is the anode, whether it is the cathode. They can also ask you to name the electrodes, okay, and they can also suggest that you give a name. They can ask you to give the name of the electrolyte that is being used. So there are a lot of questions that can be asked about the electrolytic cell. The electrolytic cell has a source of power. That often is the battery, and it is connected to the electrodes. The electrodes are the anode and the cathode, and we shall look at what they really mean. And then there is a switch. When you switch it on, it means the electricity is going to move and complete the circuit. If you switch off, you're breaking the circuit. If you switch off, you're breaking the circuit. And then the bulb, of course, will tell you that actually the circuit is actually complete. The electricity is flowing if it lights. If it doesn't light, it means that perhaps the electric current is not flowing. So you may need to check your wiring. Okay? And then the electrolyte. The substance which, when in molten state or in solution, can conduct electricity. That is what we call an electrolyte. And we saw that this can be a strong electrolyte when it completely dissociates to form ions. It can be a weak electrolyte when it partially dissociates to form ions. And then now, the two electrodes. The first one is the anode, which is connected to the positive terminal of the battery. And then the cathode, which is connected to the negative terminal of the battery. We can see it here. The positive terminal is that plus there, connected to the anode. So this is actually positive electrode. And then this, the negative terminal of the battery, is connected to the cathode, which is actually negative. There. So that is what we call an electrolytic cell. And we have looked at the connections. These are wires, these ones here are wires that are connected to the bulb here and things like that. Okay? Now let's move. So what happens at these electrodes? There is a migration happening. Remember, the ionic solution contains what we call ions. The positively charged ions and the negatively charged ions. The positively charged ions are the ones we call the cations. The negatively charged ions are the ones we call the anions. Okay? Now, there is a migration happening within the solution. The positively charged cations go to the negative electrode. So they come here, just like you see them here, they are around the negative electrode. The negatively charged ions move to the positively charged, the positive electrode, which is we call the anode. So that's why we see them here. So that is what is happening. The other thing that is happening is that you have what you call half reactions happening. The ones that we saw earlier on. You have a half reaction here, you have another half reaction here. Okay? So, at those half reactions, we have the oxidation and reduction. But what gets oxidized and what gets reduced? That's the question. Do we know the answer? The answer can lie in what ions do we have in that solution. If it is a dilute solution, if you see this solution, it means you have water in there. So you also have ions that are coming from water. So for example, here you're seeing that you have water giving us hydrogen ions and the hydroxyl ions. And then you have the ions that come from the electrolyte itself, basically the salt in this case. You have those sodium ions and the chloride ions. Remember, the positives move to the negative electrode. The negative ions or the anions move to the positive electrode that we call the anode. Okay? So in a solution, don't only think about the ions from the electrolyte, also think about the ions that come from water. Okay? So you have, in this setup, you have 4 types of ions. And they follow that migration pattern that we have just explained. Now, one of the things that will happen at either the anode or the cathode or at these electrodes is what we call discharge. You have loss of charge. You have loss of charge. So the chloride ions can lose charge and you have chlorine gas coming in. Okay, so why do we have certain ions losing charge and others not losing charge? So there is what you call preferential discharge. What rules do we have there? What factors do we have to be aware of so that we know that this one will be the one to be discharged and this one will not be discharged? So that's what we are looking at the moment. The first thing is first understand the nature of the electrolyte. Like I've just said, if it is in aqueous solution, if the electrolyte is in aqueous solution, it means that you have water in there, and the water will give you the hydrogen ions and the hydroxyl ions. and those ions you add them on top of the ions that are coming from the electrolyte or the salt in this case. Okay, so that means that the competition will always be there. The competition is not for the ions from the electrolyte alone, but you also have the ions that are coming from the water. Okay, now the deciding factor there will be the relative ease of either oxidation or reduction of water compared to the ions that are present. Okay, how easy is it to have the ions from water or the ions from the electrolyte being discharged? It depends on the relative ease of discharge or oxidation. Okay, but in molten state, where you don't have water in there, you will have only the ions from the electrolyte, and therefore that means that you are not having competition from the hydrogen ions and the hydroxyl ions that come from water. Okay, but there is also competition even if the ions are from the salt or the electrolyte. That competition could be determined by the ion that has the lowest ionization energy, or the one that has the highest electron affinity, will be discharged more easily compared to the other. So that's factor number one. The second factor is the relative ease of oxidation or reduction. You have different elements, and these elements do not have the same extent to which they can lose or even gain electrons. Okay? The extent is not the same. There is a list. There is a list of these metal ions and the relative ease with which they actually lose electrons. What we call the electrochemical series. Okay, so the electrochemical series tells us the relative ease with which you'll have cations, or you'll have metal ions or anions, either gaining electrons, or that is for the anions, or the ease with which metal ions release electrons. Okay, so that can guide us in deciding which one will actually get discharged first. Okay, so the electrochemical series is here. It's the list of elements arranged in order of the relative ease with which they can lose electrons, which is oxidation basically. Loss of electrons is oxidation. So potassium, calcium, sodium, magnesium, aluminium, zinc, iron 2, lead, hydrogen ions, copper, and silver, increasing ease of losing electrons. That means that the one down easily loses compared to the one up. It's the same thing with the anions also here. Okay, so that electrochemical series has ions, the cations and the anions. Okay, so the element that is higher is not going to be discharged in preference to the one down. The one which is down is going to be discharged in preference to the one above. So if you have sodium and the copper will get discharged compared to the sodium, because copper is lower in the electrochemical series. The one lower gets discharged first. Okay? Yes. That's what it means. The one lower can easily lose electrons compared to the one upper. That's the concept that you need to remember. So, and we have one particular example here. Electrolysis of dilute sodium chloride. Dilute sodium chloride. Dilute means that there is water in there. So the ions that you have are coming from sodium chloride and also the water. Okay, so you will have sodium ions, you have the chloride ions, you have the OH ions, hydroxyl ions, and then the hydrogen ions. Are we together? So, like we said, at the cathode, you have the positively charged ions. So you will have this one and this one at the cathode. But we are saying that hydrogen gets discharged instead of sodium. Why? Because hydrogen ions are lower in the electrochemical series. Let's go back to that electrochemical series. Sodium is here. Hydrogen is here and sodium is up here. So this one gets discharged and this one does not get discharged. Okay? So losing charge means that you gain electrons, and here you have hydrogen being released at the cathode. And then at the anode you have all the negative ions there, the anions there. So you have the OH and then the chloride there. Now, here we are saying that the hydroxide ions actually get discharged instead of the chloride ions because of the same reason. Let's check. These ones are lower compared to the chloride ions. So the rule is actually respected, right? Yes. So that is how you really know what will get discharged in preference to the other. Know the nature of the electrolyte, know what ions are there, and then know that electrochemical series. The one down gets discharged in preference to the one above. So how do we apply electrolysis? We apply electrolysis in industrial preparation of gases. Chlorine, hydrogen, and oxygen can be prepared using electrolysis. Extraction of metals, for example, sodium, you will have molten electrolysis of molten sodium chloride to get sodium. Okay, and we'll look at that method in details in a topic called extraction of metals. You can check it up on the app or on the YouTube channel and see the electrolysis of sodium chloride to generate sodium. Okay? Yes. So that marks the end of this presentation. Here we have looked at electrolysis. Okay? The key emphasis has been on what happens at the anode and the cathode, and why you have some ions getting discharged in preference to the others. Okay? And the key point is about the nature of the electrolyte and the position of the ion in the electrochemical series. Thank you for listening.